All right, here we go. This is the quadratic formula lesson. So, this is interesting, but basically there's a formula. So these things we've done have been kind of like, things that have been proven over time. This is the one way that, again, will work no matter what. If you have a quadratic formula, again, x squared plus bx plus c, this is a quadratic. This formula will work for any of them. So it goes like this. X equals negative b plus or minus the square root of b squared minus 4 times a times c all over 2a. So make sure you have that written down. And so that's kind of a complex formula, right? Can be difficult to remember. The good news is there has been a lot of people that have made parodies to help us remember this. So the classic one is to the tune of Pop Goes the Weasel. So we'll play this one first. Oops, shoot.
The quadratic formula's negative b plus or minus the square root of b squared minus 4ac all over 2a. b squared minus 4ac all over 2a.
So that's kind of the classic one that, I've had kids hum that while they're taking a test. Absolutely. This one's pretty cool. Sounds a little better. But
plus or minus the square root of b squared minus 4ac all over 2a. Minus the square root of b squared minus 4ac all over x is equal to negative b plus or minus the square root of b squared minus 4ac all over 2a. Minus the square root of b squared minus 4ac. X is equal to negative b plus or minus the square root of b squared minus 4ac all over 2a. X is equal to negative b plus or minus the square root of b squared minus 4ac all over 2a. B squared minus 4ac all over 2a.
so those, if you look, there are quite a few of them. If you want to scroll through and, get some ideas, I will say that we'll definitely offer some extra credit if you are interested in creating your own remake. So I don't offer extra credit very much, but that is one way that you can get extra credit, is to create your own quadratic formula, song, remix, whatever you want to call it. So let's go ahead and use it. We can't just be able to sing it. We got to be able to use it. So again, this is not equal. This is not into the correct form. Maybe I'll add that because, again, we have to have our function equal 0. So this is equal to 2. So all we have to do is subtract it on both sides. And then we've got the correct formula that we need. Minus 2. Minus 2. So x squared plus 3x minus 2. And I would go ahead and label your a's, your b's, and your c's. So there's no coefficient for the 1, or for the x here, x squared. So we're going to assume it's a 1, okay? There's no coefficient. You assume it's a 1. B, the coefficient is a 3. And C, the coefficient is negative 2. So now we're going to take our formula, and every time I see B, I'm going to plug in 3. Every time I see A, I'm going to plug in a 1. And every time I see a C, I'm going to plug in negative 2. So x equals, I'm not much of a singer, so I'm going to save you from that. Negative 3 plus or minus the square root of b squared, so negative 3 squared. Oops, it's not a negative, it's just b squared. 3 squared minus 4 times a times c all over 2 times 1. So now we can start simplifying. Negative 3 plus or minus the square root. 3 squared is 9. Negative 4 times 1 times negative 2 is negative 8. So that's going to leave me all over 2 times 1 is 2. So x equals negative 3 plus or minus. This should be a plus 8 because negative 4 times negative 2 is a positive number. The square root of 17 all over 2. And so that's about as far as I can go, but I can split it up. So I can say x equals negative 3 plus square root 17 over 2. And x equals negative 3 minus square root 17 over 2. So those are my two solutions. Again, they're approximately about 0.56 and approximately negative 3.56. So we had two solutions in that one. Another example number 2, could be (25x squared minus 18x equals 12x minus 9). Again, it's not in the correct form, so I have to subtract negative 12x on both sides, and I have to add 9. So I'm going to rewrite this as 25x squared, negative 18 minus 12 is negative 30x, plus 9 equals 0. That's what I want. Now I can go ahead. Again, I suggest you label what your A, B, and C is. A equals 25, B equals, I forgot an X here. So you can see, even I am having, there are so many small little steps that if you try to hurry or if you don't show good work, you can make a silly mistake that will goof up the entire thing, and then you have to start all over again. So x equals negative 30 plus or minus the square root of b squared, negative 30 squared minus 4 times 25 times 9, all over 2 times 25. Negative 30 is 30, plus or minus the square root. Negative 30 squared is 30 times 30, or negative 30 times negative 30 is going to give me 900. Now, I do suggest you do all this multiplying and showing your work, because if you try to do it in your calculator in one step, you're going to have trouble. So x equals 30 plus or minus the square root of 0 all over 50. Now, whether I add the square root of 0, subtract the square root of 0, my answer is going to be the same. It's going to be 30 over 50, which we can reduce to 3/5. And so this is a case where you only have one real solution, because again, 30 plus the square root of 0 divided by 50, or 30 minus the square root of 50 divided by 0 is actually the same thing. So again, when in a case of a quadratic, would you have something that looked like this? If your graph only touched one time. Okay. Whereas in this case, above here, we had 2. Your graph would look something like this, where it crosses your x-axis twice. And of course, we got to build off last lesson. What about those imaginary numbers, right? What if we had negative x squared plus 4x minus 5? So again, what I'm going to do equals 0. I'm going to label A is now negative 1, B is 4, and C is negative 5. X equals negative 4 plus or minus the square root of 4 squared minus 4 times negative 1 times negative 5, all over 2 times negative 1. So as we begin to simplify, negative 4 plus or minus 4 squared is 16. Negative 4 times negative 1 is positive 4, but positive 4 times negative 5 is negative 20. 2 times negative 1 is negative 2. So these do take a little bit of work, right? They do take a little bit of time to do, but you're really going to want to show your work, or I can almost guarantee that you'll make a silly mistake. Now this is where, hey, I've got that -4, so I can move that negative out of the way by using the imaginary number. And then again, the square root of 4 is 2. So the square root of -4 equals 2i. So -4 plus or minus 2i all over -2. And I'm just going to simplify. Okay, I see that -4 divided by -2 can be reduced to a 2. And then positive or negative, okay, that's going to stay the same, but 2 divided by 2 is going to cancel out. So I'm going to be left with 2 plus or minus I. I'm fine if you write it like that. I'd also be fine if you did 2 plus I, 2 minus I. Two different ways to write the same answer. So again, quadratics always have two solutions, even if they are imaginary. Now we have this kind of special word called the discriminant. And we find that from our b squared minus 4ac section, okay? So that part that's underneath our square root sign, if we go all the way to where did we write the formula? This part that's underneath our square root sign, b squared minus 4ac, that is technically the discriminant. So what we can do is we can determine that, hey, if b squared minus 4ac is greater than 0, I'm going to have two real solutions. If b squared minus 4ac equals 0, I'm going to have one real solution. And if b squared minus 4ac is less than 0, I'm going to have two imaginary solutions. Okay, we always have two solutions. Or excuse me, we always have, quadratics have two solutions whether they happen once or twice. So if I look at this, again, what would this look like? Draw some quick x and y axes here. Could be something like, we kind of showed these two already, the first two. Got something like this. You might have something that only touches once, like this. And then you could have something that initially doesn't look like it touches, but again, when you graph imaginary lines, remember your x-axis is the real numbers, your y-axis is the imaginary numbers. So again, you can just use this, so you could say, use the discriminant to tell us how many solutions there are. Okay, so again, it might just be like a shortcut, like how many solutions are there? Is there one? Is there two? Are there two imaginary numbers? So that could just be a fair question that I just ask you is, how many solutions are there and what type are they?